What I'm going to talk about in this segment are local definitions. That is, definitions that are not like functions which can be used anywhere inside a module. These are definitions that only belong inside another definition or inside an expression. So we'll start off, the key one we'll look at is where, which is a definition that's local to a function. And as I said in the previous segment, these things are really helpful if we want to think of breaking the problem down into smaller parts. And what we'll do is look at a particular example from the pictures domain, and we'll look at a function that takes a picture, like the horse you see there, and produces the picture on the right. So you get, in the top left-hand corner, the original picture, underneath it, the picture inverted color. In the top right, you get the picture inverted and flipped, and in the bottom corner, you get the picture just flipped. Now, what's a way of describing the answer to this? One way we can do it is this. We can say that 4 picks applied to pick is 2 halves, the left half beside the right hand half. And then separately, in the 2 definitions of left and right, we describe what's the left half and what's the right half. So that breaks the problem down. And then we can see that there are a number of different ways we might use these local definitions to complete the problem. Okay, so let's just to reiterate, left and right are defined, but they're only usable inside this function. So they're applicable to the function, to giving us the answer, but we can't use them outside the definition of 4 picks. And then to complete the answer, we have to complete the definitions of left and right. And one way of starting is to say, well, how do we get the left-hand side? And what we can say here is we take the picture, which is a black horse on white background, and put it above the same picture where the colours are inverted. So it's then the white horse against the black background. So there we've got the left-hand half described quite straightforwardly. Now we can see there's a number of different ways we might use this collection of local approach using the local definitions to describe the right-hand side. The first way of doing it is just to describe the right-hand side as we described the left. So here what we're saying is, how do we get the thing in the top right-hand corner? We take the picture, flip it in a vertical mirror, and then invert its colors. And we put that above a picture where we've flipped the horse in a vertical mirror, flip the picture in a vertical mirror. So it's invert of flip V of pick above flip V of pick. Okay, so that gives us one approach. We said what the left was, now we say what the right is from scratch. How else might we do it? One way is to add another, what I've called a helper definition. And this is this thing sip. It's sip because it's pick backwards, and pick backwards is got by flipping pick in a vertical mirror. So we've got sip is defined to be flip V of pick, and then we can say the right is invert of sip above sip. So we've added this extra definition that does the flip in a vertical mirror, and then we can describe the right in terms very much like the left. We've got a picture, we've got an inverted picture above a picture instead of a picture above an inverted picture. So that's nice and symmetrical. So we've added another helper definition, another local definition. That's one way of doing it. A third way of doing it, and I think this is my favorite, I think, is that we use the left-hand half, what we've defined as left, in defining what's on the right. And the way you get the thing on the right from the thing on the left is to flip the whole thing vertically and then invert the colours. Or indeed, we can invert the colours and then flip. It doesn't matter which way we do those two things. They're what's called commutative. So here we've defined one of these columns, the left column, and then we define the right-hand column directly in terms of the left. So we've used one of these local definitions in defining another local definition. So right, we defined left, and then right is defined using left. And finally, I'm defining what's called a local function here. So I'm defining a function called stack p, which takes a picture p and puts it above the inverted version of that picture. So whatever p is, we get the picture above its inverse. And then we can define left and right. Left is got by stacking pick itself. We put the pick above invert pick. And we get the right hand side by putting invert a flip of pick above its inverse. So we can use that local function. So we use that locally defined function stack of p in defining both left and right. And again, this is a local function that we can only use inside the definition of 4 picks. Now, there are two reasons we make definitions local. One is because they use things that aren't available outside. So left and right are defined using pick, and that's an argument. So we only have that argument when we're inside the function. But another reason is if we define a local function like stack, it may only work inside the enclosing definition because it uses some things that are local. But also we might do it just so that we don't have too many names in our in a module. The only time we want to use stack is in this picture, so let's make it in this definition of 4 picks. So let's make it local to that definition. Okay, so that gives you, I hope, a feel for what's going on here. We can, when we're writing an equation that defines 4 picks, we can use this where clause to define a number of local definitions like left and right, or local constants like local functions like stack, and build the answer using those locally defined things. Now, if you'd like to try doing this for yourself, we could have approached the problem differently. We could have broken the problem down and said it's the top line above the bottom line, and then inside some local definitions, we could define top and bottom. You could try that, modeling that on what we did with left and right just now. You could try to define what we have in here, this function we're trying to define, using the breakdown of top and bottom.